equals the limit from the right, and must equal
the limit as x approaches, or fx as x approaches a.
So the limit from the left equals the limit from the right, and it must equal something else. Otherwise, it's not continuous.
Is it not the limit of f of x as x approaches a?
Yes, so the limit from the left, but this is the limit as x approaches a from either side. That's what this means.
Oh, okay.
And equals what? Otherwise, it's not continuous. Otherwise, it's like this. And this is not continuous. What else has to equal to?
Is it f of a?
Exactly.
Okay.
Exactly. This is the definition of continuity at the point. Not only that the limits from the left and from the right are equal, but also equal the function value at that point. Awesome. Another super important concept was differentiability. Here's the graph. I just made it up. Is this function continuous?
No.
Where is this function not? Yes, correct. Where is this function not continuous?
X is equal to 5.
Perfect. It has a jump discontinuity. Awesome. Is this function differentiable? It's not differentiable at 5, right? So x equals 5, not continuous. So x equals 5, not differentiable. We know that if the function is not continuous, it cannot be differentiable. What about, forget about 5. Is this function differentiable everywhere else?
Not at 4.
Not at 4. X equals 4. Although it's continuous, not differentiable. Why is not differentiable at 4? Awesome. What is the reason why?
Because it's a sharp turn.
Yes. Excellent. It's a sharp turn. Awesome. Great job. And the last concept that I can think of right now is number 9, differentiation rules. Rules. And you know all the rules that we talked about. Product, power, quotient, chain. That's all we studied in 5 weeks. 4 weeks. Okay. So what I would like to start with, you tell me if you want to start with something specific. Do we know how to determine the average rate if we have 2 points? Should we even discuss this again?
Yeah, can we do a problem?
Okay, because I really would like to get to the core of the things. I mean, this is, if we have a function f of x equals 2x plus 1, and let's say x equals 1 and x equals 2, I find f of 1 and I find f of 2, and we know how to determine that. And then the average rate will be f of 2 minus f of 1 over 2 minus 1. Is this okay?
Yes.
That's all we have there. That's really nothing. This is from algebra. Do we know how to determine derivatives? Do we want to work on any of the derivatives? It involves differentiation rules. Do you have any?
Can we just do
yes,
1 or 2?
Yes, any problem. Do you want to choose anything?
I don't have a certain problem.
Do you want a particular type? I mean, we had this. This was an example of f prime and f double prime. So this is what this is all about. We're asked to find the derivative. And we apply the product rule here. We apply the product rule and the chain rule.
Yeah, can we do another product and chain rule one?
Yes. You want a product? You want a quotient?
Product.
Okay. Do you want to choose another product, or you want us to make one up? You want to make one up?
You can make one up.
Okay, so let's say 2x minus 3 to the fourth times 5x squared plus 8x to the third. Is this a good example, or you wanted something else?
It's good.
Okay, so let's find f prime. So f prime of x. So let's differentiate 2x minus 3 to the fourth power. How do we do that?
It's 4 to x minus 3 to third.
Don't ever forget times the inner function prime. If we forget to say times the inner function prime, the whole thing collapses.
Times 2.
Excellent. Times 5x squared plus 8x to the third plus. I copy the first one. Times. Now I'm here and I'm differentiating this.
It's
10x
3.
plus 8.
So you said 3. 5x squared plus 8x to which power?
2.
Good. Times the inner function prime.
And x
Plus 8.
plus 8.
Excellent. Perfect. So now 4 times 2 is 8. 2x minus 3 to the third. 5x squared plus 8x to the third. Plus, put the 3 in front. 2x minus 3 to the fourth times 5x squared plus 8x squared and times 10x plus 8. I didn't do anything, I just copied. I wrote 8 in front and I copied this and I copied this, and then plus. I put 3 in front and I copied this and this and this. I didn't do anything else. I just rearranged it. And now this term and this term have a common factor, or common factors. What do they have in common?
X minus 3.
Yes. 2x minus 3, which power?
3.
Third.
Excellent. Good. Now also I see this. To which power?
2.
Yes. Good. So now let's see what is left from the first term. An 8 is left. These are all out. From 3, I remove 2. So how many are left?
1.
Yes. A 5x squared plus 8x. Awesome. We're moving on to the second term. Plus. 3 is out. Stays in. From 2x minus 3 to the fourth power, I took out 2x minus 3 to the third power. So how many are still left in?
1.
Yes, a 2x minus 3. Good. Now these are gone because I had to and I took them out completely. But then I still have 10x plus 8. Just to make sure that you understand, a problem like this is not going to, I don't put problems that are so extensive, so long on a test, because it took me to explain. Of course, I'm slow because I have to explain each step and I have to wait and have a conversation with you. I don't want to just do stuff. So a problem like this is a little bit too extensive for a test. So using the product and having to simplify on test 1, it's not going to be that extensive, just to make sure that it's clear. On test 2, when we do something else, you'll see what, it's a different story, but I don't want my students to spend 15 minutes on a problem. Okay, so as you see, it takes me a while to factor and then distribute here and calculate and this and that, right? So I don't want my problems on the test to be that, write 2 pages on a problem. I don't want that, because I'm testing basic understanding of the rules and the concepts. So I have to copy these two. 5x squared plus 8x squared. And now I have to distribute. So I have 40x squared and plus 64x and plus. Do not distribute the 3 like we discussed before. Multiply these 2 because then it will be so much easier to distribute 3 once. Then distribute it here and then make all the numbers much bigger. And that's my suggestion. It's up to you. So 2x times 10x. So 2x plus times 8. And then minus 30x. And then minus 24. See, it takes me, I know I write big, I write with markers, but it takes me a page to finish this up. So 2x minus 3 to the third. 5x squared plus 8x squared, and then I have a 40x squared and plus 60, 3 times 20, 60 plus 40, 100 x squared. Then I have a 64, and this is negative 14 times 3. So 64 minus 14 times 3. So 14 times 3, I have 52. No, 42. So minus 42x. And then I have this, minus 672. So I have to write one more step, simplifying this into 64 minus 42, which is 22x. And this is it. This, 100x squared plus 22x minus 72. Good. Now I would like to move on to the next concept. My pages are not in order here. Okay. So we know how to find f prime. We know how to find f prime and plug in a number, right? So once I have f prime, if I want to determine f prime of 0, what will I do? Plug in 0 here, plug in 0 here, 0 here, and so on and so forth. Or plug in whatever, f of 1, right? We know how to do that, correct? Plugging in a number in here and finding f prime of a. I should have written just the number in here, f prime of a. Yes? What about finding the average cost, average profit, or average revenue? Not all 3, one or the other, one or this or this or this in a problem. So let's say we are given, say it again.
Can you do a problem from chain rule? I have one.
Yes, let's do a problem from chain rule. And then we'll come back to the rate of change of the average cost or average revenue or profit. Yes, I'm ready.
Is 4x cubed over 7 minus 5x 5x 7 minus 5x parentheses 3 power to 3. 2 power. Yeah.
Okay, so we have the function 4x cubed over 7 minus 5x to the third power. Is this the function that we want to differentiate?
Yes.
Okay, so now here you have several options. But definitely, since this is a factor and nothing else follows, I will definitely do this. Absolutely. Not involve the constant. Remember, a very important rule is if a constant multiplies a function and we are differentiating this, keep the constant outside. It will not go away. but not involving the constant will make our life easier. Is that okay so far?
Yes.
Okay, so then we have 4x to the third over 7 minus 5x to the third, and we want to differentiate. I could change it also into a product, but let's say I'm doing what we see here. Okay. The top function prime, can anyone give us the derivative of the numerator?
3x.
Careful.
3x squared.
3x squared.
Very good. Times the denominator. And then don't forget the minus. We are keeping x cubed, but now we have to differentiate this, and in the denominator I have to square this. Which power will it have if I have 7 minus 5x cubed and I have to square the whole thing?
To the 6.
That's it. Copy the base, multiply the exponents. Awesome. So now I have to differentiate this and put it here. Watch me run out of room. Can anyone differentiate this for us?
Be 3, parentheses, 7 minus 5x to the square.
Excellent. Times the inner function prime.
5.
Careful, one more time.
Be 0.
Careful, one more time.
So -5.
Thank you very much. The derivative of 7 is 0. The derivative of negative 5x is negative 5. Do we all agree so far? Yes?
Yeah.
Perfect. Good. So now let's continue because this is not done. So 4 stays outside patiently waiting. You cannot distribute anything, but I have to rearrange this because it's all over the place. So I will copy 3x squared and 7 minus 5x to the third power. Now I have negative 1 times 3 times negative 5. Negative 1 times 3 times negative 5 is positive 15. Yes, x to the third, and then 7 minus 5x squared over 7 minus 5x to the 6. Do not be tempted to simplify anything. It would be a tragedy. So now we see that this term and this term both have common factors. Do not look at the denominator. Do not touch the denominator. So what are the common factors at the top?
3x squared and 7 minus 5x to the
3x
to the power of
squared
2.
and 7 minus 5x to the second power. Awesome. From this term, I have 3 out. I have x squared out. And from 3, I removed 2 of them. So what is left inside?
Seven minus 5x and then
Awesome.
plus
Good.
5x cubed.
So 3 times 5 is 15. From x cubed, we took out 2 of those. So what is the power left?
It's 1.
1. And these are completely out. Good. That's it. Now, and only now, I can simplify. What can I simplify? How many are left?
4.
That's it. Notice that these 2 are gone. 7 times 3, 21. 21 times 4, 48. What is it? 21 times 4, I'm sorry, 84. X squared over this, 7 minus 5x to the fourth. So 7 times 3, 21. 21 times 4, 84, and x squared. And this is final. No one can further simplify it. If I had involved 4, I would have had bigger numbers to worry about. And why? This little thing is a constant. Now, don't change anything. But if I have this, I'm stuck. Don't change anything. I'm stuck. I can't do that, what I just did here. I have to use the 4, and I cannot separate it from the rest. But if I can simplify it, I will always do it.